for the cloud.
And it's 9 o'clock, so open her up.
Alrighty. Hello, thank you everyone for joining us today. We're going to be talking about BIM Revit 101 for Building Performance Analyst. This is part of the Building Data Exchange and the BIM to BPM working group, which I'll tell you about in a minute. We have our guest lecturer here, Yu, joining us. Just as introductions, my name is Justin Schultz. I'm a senior building performance analyst with EYP. That means I'm one of you guys, one of these analysts trying to convert architectural models into energy models for an integrated AE. So I'm right there in the weeds with the architects working on the models. So I'm really trying to find ways to streamline that process. That's why I am co-leading, or actually leading, not co-leading, a BIM to BPM working group, which is building information to building performance modeling working group. So really looking at not only just building energy modeling, but also daylighting modeling and other types of modeling, which is a subgroup of ibpsa-usa's Building Data Exchange committee. I'm also joined here by Yu.
Hey everyone, my name is Yu Chen. I'm a building performance engineer at Zero NB. My background is a mechanical engineer, and I have been an energy modeling practitioner for over 6 years. My day-to-day work is mostly energy modeling. I also work on many other things such as BMS data analysis, writing code and developing scripts for energy modeling workflow automation, thermal comfort study, many other things, but mostly related to building performance. So for Revit, my experience is I have started using Revit ever since I started doing energy modeling. And I really love the tool. It's really great at creating geometry for energy models, in my opinion. So I put together this demo as a tutorial. So hopefully for anyone who's interested in learning using Revit to create the geometry for energy modeling, this can be a good resource. So yeah, I hope you guys will enjoy the video.
Great. And everyone can see my screen, right? I just want to clarify that screen is sharing, right? Can you see it?
Yes, I can see it, yeah.
Great, okay. Thank you, everyone. So as a real quick recap to what I was just highlighting, BIM to BPM stands for Building Information Modeling to Building Performance Modeling. We're a working group as a subgroup to the Building Data Exchange. Our goal is to improve industry knowledge around translation of building design models, in other words, architectural BIM models into building performance models. We're a group of practitioners. We are not, tool developers. We're not part of, we're not necessarily the other tools out there that's promising an easy translation. We're practitioners ourselves trying to document best practices. So we're really just trying to say, what are the best workflows available to us today to make this process much more streamlined? And that's actually why I invited you here. He did a previous presentation as part of a gbXML presentation that really opened my eyes to the simple Revit model workflow. And he's going to have a whole video on that later in our presentation here. If you are interested in BIM to BPM, feel free to reach out to me, myself, Justin Schultz, jschultz@eypae.com. If you're interested in contributing to helping writing guides, or if you're just interested in receiving quarterly updates during our quarterly meetings. So I'm going to open it up to our first poll here. I'm going to open it up and you guys can get started, but I'll read it out here. What tools, if any, do you use for translating architectural models to building energy models? So there's a series of Revit plugins that exist. There's export processes through Revit. There's Rhino and Honeybee and pollination processes, SketchUp, Fluorespace.js, the BIM application itself, and sometimes you're just redrawing it all from scratch. I'd love to hear more from you guys about, what workflows are you currently using to kind of make that geometry from the architectural model into the building energy model more seamless. Looks like so far we're getting a good response, and the go-to is redrawing, which is very, very common in practice. Don't feel ashamed to answer that. It's something I myself am doing very regularly, even though I know about a few other workflows. Some people are using a Revit export process, which is great. More and more people are seemingly picking up plugins, which are, something I'll touch base on, but we're not going to really go into in depth today. And then you can also go to the next question. when you get a second, which is what would be your ideal BIM to building performance modeling workflow. Whether that's an automatic translation directly to a BIM, or there's an interstitial step where it creates an analytical model, something like a gbXML or an analytical model in Revit, redrawing or redrawing the geometry specifically in the building energy modeling application. I'll give it one more, let's see, another 30 seconds, and then I'll close the poll. Really good participation, though. Thank you, everyone who's filling it out and answering. I appreciate that we got like 75% of you have already filled it out. So if you're that 25%, you have 10 seconds. Great. Thanks, everyone. Let me share the results here so you guys can all see it. Very interesting information. A lot of you are redrawing, which is very, very common. More of you are using the export plugin available, or export features available in Revit, which is great. SketchUp still has a huge market share, although there's more open source development of that now, and some people have transitioned to plugins. Additionally, people really do want a direct translation, something that's more automated, which is great. I think there's some future applications of that coming down the pipeline, but it's something that I'll get into here in a minute. So as a recap, and for those that don't know, what is BIM? BIM in its definition is a shared digital representation of built assets to facilitate design, construction, and operation processes to form a reliable basis of decisions. BIM tools are often used like computer-aided design, CAD, but with a lot of data underneath. In other words, we're using it to convey construction and design intents. And BIM helps architects, engineers, and construction teams create high-quality buildings. So many of us think BIM and we automatically translate to Revit, although there are other BIM tools that exist. So what is the interoperability dream here? The hope is that we can take BIM models, like as sufficiently detailed you see here on the left, and immediately translate them over into an energy model. The problem is that often doesn't happen very seamlessly, and I'll get into that in a minute. And then there's also a longer term perspective of, can we take information from the energy model and bring it directly into the BIM model? Things like diffuser sizes, CFM requirements, ventilation requirements, people loads, lighting loads, all these things that we need, which would be a really, really powerful information, especially back to mechanical engineers, electrical engineers, et cetera, to help us design our buildings. The problem is that the process is not often very streamlined. The old saying, garbage in, garbage out. And it's very true when it comes to translation of architectural models to energy models, but that's not necessarily the fault of either party. We're developing models for very different purposes. Building information models are used for construction. Their true intent is visual clarity. They want to be able to provide enough visual clarity that there are not problems in the construction of a building. They're creating and managing information for a built asset, while building performance modeling, on the other hand, is to evaluate building performance, code compliance and sustainability checks, and create and manage information for performance. The overlap is geometry, building systems, people, zone information, thermal zone details, space types, et cetera, things like that. But they really do have different purposes. And we need to keep that in mind, because architectural models are rarely set up in a way that immediately transfer to a building performance model. That translation process is done in a number of different ways. There's what are called schema, and it's a method of transferring data between applications. The one that's probably most familiar with everyone on the call here is gbXML. And it is a very common schema for taking architectural design, translating into building performance simulations, energy engineering design, et cetera. But the intent I want to bring here is every one of these, taking an architectural model and bringing it into a schema, requires something called translation. And that translation process is something that we as designers, as practitioners, don't have a lot of control over. Now, we do have some control, but at the end of the day, it means that there is a computer making decisions about how to translate the exterior wall, shading, glazing, overhangs, all these things that we have in our models that can work very well sometimes, and other times result in very messy exports. However, there's a number of tools available in the market that are trying to circumvent this. I'm sure many of you have heard about what Cove Tool and Pollination are trying to do. They're promising a more direct translation from architectural Revit models, Rhino models directly into energy modeling, which is absolutely wonderful. However, it does mean that sometimes you do not have more control about that translation, about how that translation process occurs. Other tools like Revit, SketchUp and Trimble and Bentley are other kind of architectural-based geometry tools that have energy modeling functionality by doing gbXML export or having plugins associated with them. So these tools are very, very great, and I'm very excited to see where they go in the future. But we do want to discuss today another workflow, and this is the simple modeling method. It's taking a Revit model and translating it directly into a gbXML for export into a building energy model. The process, though, isn't one where you take the architectural model and translate it directly. You actually redraw it with your understanding of how building performance works so that you can draw your thermal zones. You can understand how those things occur. Some of the advantages are that drawing in Revit is generally faster than doing so in your building energy modeling tools. Revit is a drawing tool first, right? While BIM, building energy modeling tools, are an energy modeling tool. So yes, many of them have built-in geometry drawing, but sometimes Revit's just better because it's its primary function. This method is consistent and reliable. It provides a much more way in which you have full control over the thermal zones. You know it's going to work almost every time. The other factor is it's connected to the architectural model, which you will go into in the video, and it exports to gbXML very seamlessly, and future exports to IFC are in the works as well. The disadvantages are, it's another tool that us as building performance analysts need to learn. There's some basic Revit skills that you need to understand, but Yu's going to go through those here soon. And there's some setup, especially in the Revit template side, which can make this process much faster and more seamless. And you still need to redraw. So it's not a direct translation process, but it's one which you have control over. And that can be really relevant to how we create our perimeter zones, how we zone multiple similar space types together to allow us to make our energy modeling process faster and reduce the number of thermal zones we have to model. So I'm going to stop sharing for a brief moment so that I can switch over to the demo. This is a video that was put together by you, and we're going to stream it here. So if you guys have questions while this is occurring, please drop them in the chat. We will be actively participating in them so that you can watch along and learn. All right, should be going here.
Hey everyone, my name is Yu Chen. I'm a building performance engineer at Zero Envy. In this video, I wanted to show you how to create an energy model geometry in Autodesk Revit. There are so many ways you can use to create the geometry. You can use other tools like SketchUp. You can also directly create the geometry in an energy modeling software. But here at Zero Envy, our go-to approach is to use Revit. We found it's really efficient and it's a big time saver, especially when it comes to bigger projects. So we just want to share that knowledge. And in this video, I'm just going to walk you through a quick demo to show you guys all the steps and what it takes to complete a model in Revit. And then I hope you guys can have a better idea on how the entire workflow looks like. So yeah, let's jump into it. So the first step is to link an architectural Revit model as a background in our blank Revit file. So the whole idea here is that we want to have this background and we can trace it. It is really hard to directly export an architectural Revit model to a gbXML file. Usually you will just run into a ton of errors. So we just wanted to have this background and we can trace it to create a cleaner geometry that we can export to a gbXML file successfully. So in order to do that, you will go to Insert and click on Link Revit and pick the file you want to import and open. Usually it takes a second to load. Once the model is loaded, you can look at it. So I'm going to go to the 3D view just to see if it shows up correctly for me. Looks like it's here. So it's two high-rise residential towers, and my demo, I'm just going to be focusing on one of them. So what I do is usually I will just turn on the section box in the 3D view, so I can just focus on the building that I wanted to work on. So once you have the section box, I can adjust the scope. So I'm going to just crop out everything that I don't need. Okay, so this should give me what I want. So yeah, you can rotate around and see how the geometry looks. So it's a pretty complicated building. And the next thing is basically to set up levels. So we can then go onto each level to create exterior walls, interior partitions, and etc. So in order to create levels, you can go to the elevation view.
Sorry, is it struggling for everyone or just a few people? Just want to make sure that the quality's coming in okay. Okay, seems to be good for some and not great for others. It may be it's a little blurry. Okay, well, let's keep running it through here. I want to note that there's two locations that the video will be available. The video will be available on ibpsa-usa's YouTube channel, as well as Zero MV will be uploading on their YouTube channel this video file natively. So there will be a much higher quality version of that on YouTube at a bit later time. So if you are having visual difficulties with it, there will be multiple locations. Hopefully this pause gives it enough time to buffer and catch up a little bit too.
So I have 4 elevation views created already, and I was just going to go to one of them. So all these levels here are from the architectural model. What I'm going to do is I will just create the same thing following these level numbers. So go to architecture and click on level. So we can randomly just place one level here. And I will update its name to match the actual name of this level. I'll just call it level 1. For the height, you can actually see what the height is here for level 1, and I will adjust it to make sure it match the actual model. So that's your level 1. And then it's going to be a little bit repetitive, and you will create level 2 and make sure, yeah, match the level 2 height as well. I'm just going to create the rest and come back. So I just created all the levels. As you can see, start from level 1 all the way up to level 28. I skipped the underground parking levels because, you know, it's the same method and it doesn't add more value to this video. So I'm just going to focus on the above ground floors. So yeah, the next step would be go into each level and start creating walls. So I will go to level 1. So you can go here and pick level 1. What you're seeing here is the architectural background. So this is a little confusing. It's not exactly the plan that I needed to create construction. So we need to pick a floor plan that we can work with. Here you can on keyboard hit VG to open the visibility and graphic settings. Over here in Revit links, you can see this is the link we have been using. And under display settings, you can open it, check my link to view. So this will allow you to pick a view that you want to use as the background. Sometimes it takes a little work to find out which one is the one we needed, because sometimes one view can be clear, but maybe it doesn't have room names. One view can have all the room names, but maybe, you know, the plan is just not clear. For me, I know it's north level 1 is the one I wanted. So I will choose this one and hit OK. And over here, you can make it underlay. So the view, the background is going to show up as a faded or a halftone. Click on OK. So we can see this has changed to underlay. And also you can notice like the room names are showing up now. So this is the plan I'm going to work with to create my geometry. All right, so the next step is to create external walls. One thing I forgot to mention is that we have a Revit template in which we have created a bunch of envelope components. Every time when we start a new model, we will start from the template and turn that into a project. And then we can just pick the components and from there and start creating the model. If you go to wall category, you can see we have created a few wall types here, and we have also color coded them so they can stand out once you turn the color on. And if you want to change the properties of these walls, you can open edit type and you can do a bunch of things here. You can update its name. You can change the thickness if you want, which is pretty handy. Basically, once you have created all these components and just make it a template, and every time you can just start from the template and keep reusing it. So yeah, I'm gonna start from exterior wall. And so once you pick the component, the other thing to make sure is you're setting up these constraints properly. The base constraint for our wall will be level 1, of course. And then top constraint, when you first start, it's going to be like a random number. So you want to make sure you're picking the right level. We want our wall to go from level 1 to level 2. So this is what we need. And it's going to show you the height of your wall, which is 13 feet. And that's based on like all the levels we set up in the first step. And you can also give it a top offset if you want, but this is all I need. So I'm gonna start placing the walls. So one thing I wanted to quickly mention here is that we typically follow the center line of the walls based on the architectural background. I guess people have different opinions here. You can follow the interior wall, you can follow the interior surface, or you can follow the exterior surface. And I guess the difference is that depending on which approach you choose, it will have an impact on your floor area in the energy model. Because when you're doing a takeoff on the PDF, area takeoff on the PDF, you typically use the interior surface of the wall, right? But the energy model is going to pick the center line and consider that as where the wall is. Let's say if you also follow the center line and the wall thickness is 6 inches, and you will just end up having like a 3 inches increase on each side, and then eventually you will have a larger floor area for that room. I guess just wanted to bring up this point that just be mindful that depending on what approach you choose, it's going to have an impact on the floor area. So I will just keep going to finish this floor. All right, so the exterior walls on level 1 are all created. So now if you wanted to do a quick check, you can actually go to the 3D view to see how they look. You can see the architectural background is still there. Hit VG and you can turn off its visibility and click on OK. So what's left is what I have just created, all the exterior walls on level 1. So they look good to me, and it will also be nice to compare your components against the architectural model to see if they're lining up properly. So we can just zoom in and see how the model are lining up with the architectural ones. So I'm gonna go to level 2. Here again, we want to pick a good view to work with. Hit VG on the keyboard. We can pick a view. So I want to select this north level 2. So I'll just pick it and also use underlay so it can show up nice and clean. So this is the view I'm going to work with to create exterior walls on level 2. So I will keep going and to finish the next few levels and come back when I need to work on the residential levels. Okay, so I have created all the exterior walls all the way to level 12. And this is where I start seeing there are many repeated floors, typical floors. So this is where we can use a trick in Revit to quickly build typical floors in one step. And before doing that, we can quickly examine the model, how it looks like right now. So this is what I have so far. As you can see, it's a pretty complicated shell, and there aren't that many typical floors all the way up to this point. So it was a little bit of a manual work. but from here, we can pick up the speed a little bit. So let's go to level 12. What I will do is you can select one of the exterior walls and right click on it and select all instances visible in the view. So it's going to select all the exterior walls on this floor. And then we want to copy and paste all these to level 15, 16, and 17. This building doesn't have level 13 and 14, so there are only 3 levels that are the same as level 12. And starting from level 18, it's a different footprint, and I think it repeats again based on level 18. But let's now just copy paste all these walls to level 15, 16, and 17. So we have selected everything here. You can go to copy to clipboard and do paste. Select this option, aligned to selected levels. And then we will pick our target floors, which is 15, 16, and 17. Okay, so now the work is done, but we can't see anything here because we're still on level 12. But if you go to level 15, you can see how these are created, and they're created at the correct location. And now if you go to the 3D view, you can examine how it looks like. So you can see how these 3 levels are newly created. Initially, it was just this level 12. If you go back to level 15, you can also click on one of the exterior walls and see the constraints. So the base constraint is level 15 and it goes up to level 16, and that's also correct. Yeah, that's how we can create multiple floors in one step. A quick note here. So we always want to make sure all the walls are perfectly stacked. Doesn't matter if it's exterior walls or interior partitions, we always want to make sure. For example, if we have 2 walls, one on level 1 and one on level 2, and if the wall on level 2 is right on top of the other wall on level 1, we want to make sure they're perfectly stacked. If they're slightly offset, chances are once you export this model to a gbXML file and into an energy modeling software, it's going to turn into a geometry issue, and they're probably going to be detected as small surface or slivers, and that can potentially lead to a simulation problem. So we wanted to avoid that as much as we can when we are creating the Revit model. So just to show you guys what I was talking about, so I'm on level 2 right now. I'm just gonna turn off the architectural background, and you can actually see level 1 from this view. So go to underlay and set the base level to level 1, and then you can see everything that's on level 1 that you have created. So everything looks okay, except when you zoom into this part, you can see this wall on level 2 is not lining up perfectly with the one on level 1. So that's an issue and can lead to a small surface problem in the energy model. And what we will do here is quite simple. You will just move this wall to make sure it's lining up perfectly with the one below, and that should solve the issue. Okay, so I have finished all the exterior walls. Now you can see this model looks more like the actual architectural model. We can also turn on the background to check. So you can rotate around and see if everything is matching. And the next step from here, so my workflow would be start working on the interior partitions. And again, it will just be the same process. You will be starting from level 1 and start working on the interior partitions using the same approach. I'm just gonna directly jump to one of the residential floors to show you how to complete a floor. And basically, instead of using exterior walls, we are going to pick our interior wall to create interior partitions. Over here, we also want to make sure the constraints are set up properly. So it should start from level 12 and the next level is 15. And then you can start working on the creating the interior partitions. So all the interior partitions are created on this floor. And as you can see, we have a number of multiple units, residential units on this floor. There are different types. I think this is a studio, and you have some 2B units and 1B unit. and there's a common corridor and elevator shaft and 2 stairwells. And I think this is storage, and you have a mechanical shaft as well. So I'm also modeling one zone per residential unit. The next thing, we can use the same approach because we know level 12, 15, 16, 17, they're all typical floors. So we can do the same thing as we did with the exterior walls. We can just copy all the interior partitions on this floor to the next 3 levels. So we can zoom in to pick one of the interior partitions and again, select all instances visible in the view. It's going to pick all the interior partitions for you. And then we will just do copy and paste to the selected levels. So I'll pick 15, 16, and 17. And it's down. And if you go to level 15, you can see how these walls are created, and it's exactly at where they need to be. Same thing on level 16 and 17. Okay, so I'm not going to finish all the interior partitions on every level because that's going to take a long time. I'm gonna just directly go to the next step, which is to create floors and roofs. Before doing that, let's quickly go to the 3D view to examine what we have just created. So these are the interior partitions we just did. Actually, you can also reduce the size of your section box so you can just focus on those levels. So they all look good to me. And yeah, we can then move on to the next step. So I'm gonna change the back and go to level 1. Over here, we can start working on the floors. I would like to turn off the architectural background so my components can show up more clearly. Select floor, and over here, since we're using a template and we already have 2 types of floors created, we will just pick one to use it. I'm going to pick this exterior floor. And over here, also make sure the level is correct. We are on level 1 and we are creating the floor on level 1. And over here, I wanted to use this pick lines method, which is a little more efficient. So we can just pick the center lines of the walls we created to form the boundary lines. So once you have selected all the center lines, you can go ahead and click on this edit, finish edit mode. The floor is going to be created. If you go back to the 3D view, you can see our level 1 now has got a floor. So you will just be doing the same thing for the rest of the levels. And again, use the same principle. If there are typical levels, you can just create floor for one of the levels and copy paste it to the remaining ones, which should be pretty efficient. That's all about a floor. Now I want to talk about a roof. For the roof, I wanted to focus on the top 2 levels, level 27 and 28. So level 28 is the top level, so we're going to create a roof here. For level 27, because level 28 has a smaller footprint and all this area is going to be a roof as well, we will start with level 28. So for creating a roof on level 28, we actually need to be on the next level, which is, basically the roof level. So over here, I have turned on the underlay to show level 28. And all these are the exterior walls on level 28, and which is what we will be using to create a roof. So go to roof and pick a roof component. Also make sure the settings are appropriate. We will be working on level roof. We also have a base offset. So there is a reason that we do this. So when you place a roof, the bottom surface of the roof is going to be at the same level of the wall, the top of the wall. And once you import the model into the energy modeling software, I think the software is going to recognize the top surface of the roof as where the roof is. So that means there will be a gap depending on how thick the roof is. In our case, 6 inches. You will have like a 6 inches gap between the top of the wall and the end of the roof. So my experience is that in the modeling software, it will create a shading surface that's floating on top of level 28, which is a geometry issue. And so one fix is basically give a 6 inches offset So the top surface of the roof in Revit is going to be at the same level as the top of the wall. I hope that makes sense, but I also can show you guys what I mean. Let me also use the same method to create a roof, which is to pick center lines. So we just created all the boundaries, and now you can just check this one and finish it. And then we can see the roof is created for level 28. And if you zoom in, you can see the top of the roof is at the same level as the top of the wall. If we don't do the 6 inches offset, you can see how the top surface will be floating, and so there will be a gap, and this top surface is going to become a shading element in the modeling software, and that's something we wanted to avoid. So for roof, we have always been applying a 6 inches offset, so that will fix that issue. Now I wanted to create a roof for level 27 as well. If you go to 28 to create a roof for 27, you will be looking at this view, and I have level 27 turned on as the underlay. So you can see all this area is going to be a roof. Again, we will do the same. Pick the roof component and use the simplifying method. So click on OK, and this roof is created. Now go to the 3D view again to check it out. So it looks great to me. So yeah, and this situation is happening a lot in this project. As you can see, this part is going to have a roof. There's a small roof here, and you have a roof here, and down below you have some big roofs to create, but it's all the same principle. So I think I've covered pretty much everything on the plans. Now let's turn to the elevations to create windows. Let's go back to the 3D view real quick to see how it looks. So you can see my exterior walls are kind of blocking the background, but you can still see like where the windows are. And if you click on the walls, you can actually see what's behind it. You can see the background. You can also just hide them, but this is good enough for what I wanted to show. So yeah, we want to be working on the plans to create windows, but it will be nice to also have elevations open on the side, and then we can reference it. So to do that, you can go to view and do this tile views, so you can have both elevations and plans opened side by side. We will be working on level 12 again. Over here in the elevation view, that would be this floor. So if you zoom in to this corner, which is basically this area, if you click on this, you can see that we have some windows here. So we have a fixed window over here. We have an operable window, I think, and then this is also a fixed window, and we have some spandrel panels down here. So to create a window, go to Window, and this is the list of the pre-created window components we have. And my go-to is Window Instance, which will allow you to change the dimension of the windows once they're placed in the model. So I also have a bunch of glazing types created here. The reason of doing this is because this project has so many different glazing types, and I wanted to capture it in Revit because it's going to take forever to do it in the energy model, because you just need to pick every single window and then assign construction to it. If we can do it in here in Revit, it's going to be much faster. So for each glazing type, if you go to edit, I have selected a unique analytic construction. There's a list you can choose from, so this is pretty helpful. So you will basically create a bunch of glazing groups here in Revit. Once you import this model into the energy modeling software, those groups will stay, and you can just pick the groups and change their thermal properties of the glazing. To create the window, I'm gonna just pick one of those glazing types. I will just do the fixed division to create the first one over here. So if you zoom in and just place a window here, and you can see how it shows up on the elevation, and then you can just drag it to change its width for the height, and you can change it. I know it's 9 feet, and also the seal height is 0, so it's going to go from bottom to top. And for the next window, I will pick the operable vision because it's an operable window. And you can do the same and adjust its size a little, location a little bit, and change its width. And also I'm gonna keep 3 feet as the seal height and change the height to 6 feet. So that's this operable window. And then for the next one, you can actually drag this one over to create the next one and adjust its width to make sure it's at the correct location. And this one is actually a vision, fixed vision as well. So I'm going to change it back. That's done. And now this wall has spandrel panels on it. So we will use doors. So there are different approaches on how to deal with spandrel panels. Our go-to approach is just use doors because I think it's pretty hard to like split a wall into multiple pieces and assign thermal constructions to them. The more straightforward way would be just using a door to represent spandrel panels, and you can create a unique construction for the door. So we will do that in Revit as well. So go to door, and I'm just going to pick this one, and then you can place a door here. It's intersecting with my windows now, but I can change its height to what it needs to be, and then you can adjust the width of the door. So this is the spandrel panel and the windows. I will go ahead and finish the rest on this floor and come back. So I have finished all the windows and the spandrel panels on level 12. So now again, if there are typical floors, you can just copy and paste them up. For example, let's just copy and paste the glazing. Select the one and select all the instances in the view, copy, and paste them up to these 3 floors. So they will show up, and you can do the same for the doors. Here we go. So the last thing I wanted to show is how to create shading elements, which we will be using roof to do that. Let me turn on the background real quick. As you can see, these are all balconies, but there are also shading elements for the level below, so we will need to create them. So I will just do one example. So let's do the sky, and that's on level 18. So we will go there. Basically, this part is where the shading is, and you need to have the architectural background on in order to see this. So let's pick the roof, and I'm just gonna start tracing it. So if we turn the background off, you can see our shading there. And at this point, you probably guessed what I want to do next. Here we go. We just created multiple shading elements. So we are finally at the final step, which is to create spaces. Right now, let's say this geometry is complete. We have all the walls, roofs, floors, windows, and spandrel panels. Everything's down, but we still cannot export this model to a gbXML file yet because there are no spaces yet. In order to do that, let's go to one of the floors. Let's go to floor 12. So I have the architectural background on, and you can now see all the rooms and their names and room numbers. So to put spaces here, you will go to Analyze and click on Space, and also make sure the limits are correct. So we are starting from level 12. The room should end at level 15. There's no 13, 14, remember, for this building. And also we don't want to provide any offset. So this is good. And then you can start placing rooms. As you can see how it's recognizing all the interior partitions. You can just place them one by one, or I like to use this place spaces automatically. So it will just create all 12 spaces all at once. And then you can go ahead and change the name of your spaces to match the architectural naming. But that's pretty manual work. There's a quick trick to do here, which is to use this space naming function in Revit. So if you click on that, it will ask you how do you want it to match. You want to match both names and numbers, or names only or numbers only. For this demo, I'm gonna just pick this names only, and then I'm gonna select this floor, and you can just see how these names are updated to match the architectural room name. I think I missed one room here, but you get the idea. Okay, so I will do the same thing real quick for next level. So yeah, pay attention to these limits, because the first time they show up, it will be random. So that's good. Cool. So I just did 2 floors, and now final step, which is to basically do a check. So we, in our template, we have created a space schedule. If you go in there, it's gonna show you all the spaces you have in the model. And the way we set it up is that it's already grouping the spaces together based on levels. So we have level 12, level 15. I always come in here and check if everything's making sense. I check a few things. For example, all the spaces on level 12 should start from level 12. And also they should have the same upper limit. So go from 12 to 15 is what I want. So that's correct. Same thing for this level. Go from 15 to 16. Sometimes, you can accidentally set one room's upper limit to something else, like 16, and then you will be easily identifying that here. Also, sometimes you probably didn't set up your limits properly before you place in the rooms, and there will be a bunch of limit offsets here, and you can see them clearly here, which you can then just remove them by overwrite them to 0 here. Yeah, and also make sure the unbounded height for all the rooms on the same level are consistent in most cases. So yeah, that will be the final check. All right, I think I have covered everything that I want to show in this demo. Obviously, I didn't finish that model because that's going to take a while. Instead, I've pulled up the original model that I worked on for this project, and I can quickly show you guys how to export this model to a gbXML file and an energy modeling software. So before exporting, stay in Analyze and go to Energy Settings all the way over here. Open it and click on this Edit, and then scroll all the way down to the bottom. Here, make sure this detailed elements is checked. So the reason of doing this is because if you remember, I created a bunch of glazing types in this model and have assigned them to these windows. In order to make sure they stay when you export the model, we want to make sure the detailed elements checkbox is checked. So once that's done, the model is ready to be exported. So to do that, stay in the 3D view, go to File, click on Export to gbXML, and use the second option. And this is the gbXML file rendering, and you can rotate around to see how it looks. Also go to the Details tab, and you can see the list of your rooms here. If there's anything that's problematic, there will be a warning sign in front of the room. So you can click on that room and isolate it, see where it is, and go back to the model to fix that. If everything looks good to you, you can click on Next to export to the gbXML file. So the model is exported. I've also opened IES Virtual Environment, which is the go-to energy modeling software here at Zero Envy. The interoperability between Revit and IES VE is really great. That's also part of the reason why we love this Revit to VE workflow. So If you're using BE as well, this is what you're going to do. Go to File, Import, BIM file. Select the file you want to import and open it. And it's going to take a while to load, and you can see it's going through all the rooms. And once the model is loaded, you can see all the rooms are here, and it's asking you what are the things we wanted to import into the model, into the software. We definitely need all the rooms, and we need all the shading elements, which is stored in this non-thermal spaces category. And go to next. There are other things you can import as well, but for me, I just need the geometry. So I'm just going to click through and start and finish. So once the model is loaded, you can open this model viewer too to do a quick visual inspection and see how everything looks. So we have got all the shading elements in here. All the spandrel panels are imported. These are doors, and all the windows are here. So the model looks all right by looking at it. You can also go to Model It and Model Report, select everything in Section A to generate a geometry check report. It's going to be in HTML format. So this is the report, and all these are different error categories. If there's anything wrong, it's going to show up in one of these sections, and it will tell you the name, a room name. You can either fix it in VE directly, or you can go to Revit and fix it here and export the model again. Basically go through the same process. So that's everything I want to show. I hope it's been helpful, and thanks for watching.
Great. Let me stop sharing real brief to start sharing again in non-video buffering mode to increase the sharpness. The last thing I wanted to go over really quick here, and it's on the wrong screen. Actually, one sec, let me stop and just share the application, is a tool available to many of us. This is a really excellent tool that's called Aragog gbXML viewer, which many of you may have known previously from a tool called Spider Viewer. Aragog was the spider in Lord of the Rings. So it is a play on words here. But the thing I wanted to show here is you can take the gbXML file that you just created or that you create from your own Revit model and open it right here in this application. I'm going to use their example file here because it shows some really wonderful features. The thing that's really excellent is that there's a series of reports, numbers, issues here. You can click on any of these and it analyzes the gbXML file for you. It finds duplicate adjacencies, which are really, really helpful. You could toggle them on so you can see, well, like what's going on here. Maybe I modeled something incorrectly. Another really good thing to show is slivers, tiny surfaces. This is really, really excellent. They're very, very hard to see. So that's one thing, but you can zoom in on them and say, all right, there's a tiny surface here. It doesn't like that. Maybe what I can do in my energy model as you is copying the floors up, you have a wall here above and a wall here below. Maybe you align them together in your model so you don't get so many sliver spaces. So I just wanted to highlight that this tool exists as well for those that are not as comfortable with gbXML and this process as a whole. It can be a really, really good way to make sure your openings are coming in correctly, make sure your boundary conditions are correct. So you can go to area by surface type. All right, let's look at only, why did that stop working? Maybe I have to turn on the surfaces. We can look at the interior floors. We can look at the interior walls. Do these all look correct? Let's look at our exterior walls. Yes, they are all correct. Do I have any exterior walls inside the building? That tells you inside of Revit that you're drawing a wall that has the function exterior. You need to change it back to you need to change the function to interior. So this is a really good resource just to double check your model, make sure things are coming in correctly. I like this because it's very visual, it's interactive. You can click on the surfaces and see what's going on. And then I will then take a gbXML file that I've generated after putting it through here, making sure it looks okay, and then bring in ISV. I also really like to use this when I was learning personally, and I'm still learning, frankly. Save gbXMLs along the way. Do a floor at a time. Do an export. See if there's any issues that pop up. Maybe you modeled your roof, and instead of doing the roof at the level, you forgot to set it down the 6 inches that you was talking about, which is a relatively important step because then it's not going to come in as a roof, particularly in your model. So things like that. are really, really helpful to check inside here. There's very minimal shading, underground walls, checking that your boundary conditions are correct so that when you import it, it comes in more seamlessly. So that's the last thing I wanted to share on the topic of gbXML. But this is a really powerful tool. It's from Ladybug. It's free, open source. You can import your gbXML file. They have a number of example files you can use as well to get familiar with how the translation process occurs. All right, I'm going to stop sharing briefly, or stop sharing officially now, answer some of your questions. One of the ones I wanted to answer live was from Justin Sterling. It's a question, please dispel the myth that small gaps in the surface of the energy model actually allow ambient air conditions into the model. It's actually not true. Mike, I think your mic's open, so I'm getting a little bit of echoing here. There we go, muted them. Okay, so that's actually not true. So openings will actually not create air gaps. A thermal zone is typically like an airtight condition. So if you actually have gaps in the Revit model, your thermal zone will stretch in funny ways. So like, let's say you don't have your floor to the wall, right? You didn't take your floor to the center line of the wall. You're gonna get a condition where the thermal zone beneath or the space beneath will stretch up into the floor above, or may have those kinds of funny little gaps. Air doesn't seep in, but you'll have things where the floor might not connect with the wall, which is then going to cause issues in the long term. So yeah, that's not something that occurs when you have gaps, but it may create geometry errors, which something like an ISVE geometry checker should find, the gbXML Aragog spider viewer should find, things like that would be great. Justin, you also asked about resources. That's one of the things that our group is particularly trying to focus on, the BIM to BPM working group. I would recommend checking out Zero MV's YouTube channel. They have, there's going to be this video as well as another one that focuses more on the gbXML import process, which can be really, really helpful. Another good resource is ISVE has a learning on demand section of their website. Whether or not you use ISVE, they have a video on setting up a Revit model for gbXML, basically very, very similar to what we presented here today, but goes into more detail exactly about how you have to align the roof and how you have to align the walls and seal, you know, how you set up plenums is a question I saw come up a few times, which, so I'd recommend that as a resource. It can be quite good. Other resources we're hoping to generate here and we'll bring to the ibpsa-usa webinar. So keep an eye on this space. Do you have any open tools apart from Open Studio? The gbXML viewer that I just showed was open, and a number of the tools that I asked about in the beginning are open. FloorSpace.js is free, open source. It's somewhat similar to this. It creates a JSON file of your building geometry. It can be another good way of redrawing your building that isn't directly in the BIM application. What's the best way for making surrounding buildings in this method? Do you know that one? I forget the best method.
For me, I would probably do the same way as how we are building the geometry. You can create other, boundaries and then put a space in it and set up the upper limit. So this is going to be like its own room. And once you import the model into ISVE, it's going to recognize that as a room, and you can set that to like adjacent building. Or maybe a different way would be if you just do your building in Revit, and then for the surrounding, you can actually, I think ISVE has a really good way to like scan the surrounding. I forgot like what the actual application is based on the map, and it's gonna help you to build the surrounding buildings there. So you don't have to build it in Revit. That part can be done in ISVE too. So yeah, that's my experience.
The other thing that I do want to highlight is if you don't have a thermal zone within a space, it will not export necessarily. I forget whether or not like a wall will just export as a shading element, but I believe from my experience, if you don't put a space in there, even whether or not it's from ground all the way to, 100 feet, if that's how big your neighboring building is, if you don't put it in there, it's not going to show up in ISVE or wherever you import the gbXML It needs the space to find the walls, basically. Are you aware of which universities are using the tools for teaching or mostly for research? I'm not aware. That's a great question, and I'd recommend reaching out to the tool developers. Many of them, sorry, the suppliers of the tool, many of them actually provide university or free licenses for those things. So check there maybe. How do you model a grid for natural ventilation? Do you use a rename window family, or do you have other methods? I think you touched briefly on this. When you place a window, each family you place, right, produces a different window in the energy modeling application you bring in. Is that correct?
So I guess this is a question more related to how to model natural ventilation in the software. If you know like what windows are operable windows, you can have them grouped together, and then you can in ISV again you can like use macro flow that can model natural ventilation. You can set up a window schedule, operating schedule, and actually to control it based on temperature. So if you know what windows are operable, you can assign a schedule to it and let them operate to introduce natural ventilation into the building. So I guess hopefully that answered the question.
Yeah, on the Revit side, you'll have two families. One is maybe fixed and one is operable. So when you use clicking the drop down and selecting different windows, you'll name them separately. And then when you bring them in, they'll show up as different constructions in your model, your energy modeling application. And there is where you apply the opening percentages, natural ventilation, things like that. I know this session is focused on Revit. Was thinking of an alternative tool for simulation results once you export from Revit. Do you know of any open tools apart from, focus on Revit. Alternative simulation tools, open ones really do revolve around Energy Plus and Open Studio. I have not seen many open building energy modeling tools for simulation beyond that. There's a few of them that exist, but at the moment, that's the big open source one. Other ones like ISVE, EDSL Tasks, Design Builder, all those guys, they Trace 3D Plus, they all have a pay to get in and start using. Many of them, including Design Builder and Trace 3D Plus, and maybe even EDSL Tasks, I'm not sure, have Energy Plus or Open Studio as the engine underneath. So there's still some translation there from one to the other if you're familiar with the tool. ISVE has a separate engine as well as maybe I'm not sure about EDSL Tasks. All right. Any other questions? I know we are 3 minutes over. I appreciate all of you for attending. And if you have any other questions, please feel free to reach out to you or myself. And we look forward to being able to share this knowledge with you all and improve our, BIM skills as building performance analysts. I hope you guys see, some value in this. Yes, there's a learning curve. Yes, there's a setup process, but as you could see from Yu's process, in basically 35 minutes, he drew a significant part of that building in a way that I myself, who have drawn a lot in building energy modeling tools, see tremendous value in doing so much faster. The last thing we wanted to do was post the YouTube channels for ibpsa-usa, and if you could post the YouTube channel for Zero Envy, that would be really, really great. That way, everyone has access to that. That's in the chat. The first one here that I just posted is the ibpsa-usa. There might even be a better link if anyone from ibpsa wants to share that. And then you said that directly to me. Can you send that to everyone? And then from there, you'll have some additional resources. We do hope to host a few more webinars on this topic and other topics around translating BIM. So keep an eye out for more webinars in the future. Thanks, everyone.
Thanks.
developers or researchers. And urban simulations is so much different than buildings, and trying to identify what kind of questions do they want to answer, what kind of gaps do they see is a goal. But